And we did just that to answer the following question. The question is, how did students who are English learners perform in NAEP Grade 8 Reading Assessment in 2022 compared to 2019 across different states and jurisdictions? Now, we'll be honest, we did not randomly pick this question. This question organically came up as we had to perform some NAEP analysis that required answering it a few weeks ago. So when we encountered the question, we could have answered it by doing the analysis from scratch using NAEP's excellent data explorer. But we knew this analysis already existed, and the finding that we're looking for was in some reference table. In fact, we knew it because it existed in a reference table we created last fall. And this is what that reference table looks like. There's a lot going on. I'll walk you all through it. The title is Change in Average Grade 8 Reading Scores by Selected Student Groups 2022 to 2019. The rows, well, they represent jurisdictions such as states, and the columns represent different student groups such as race, ethnicity, gender, and so on. And when we found the reference table that we need to answer the question, we quickly isolated it to these two columns, which had information about students with EL status. Now you can see the cells are color-coded. White means the 2022 score for a given jurisdiction is not statistically significantly different from the 2019 score. The azure blue represents the 22 score for that jurisdiction is statistically significantly higher than 2019. And the salmon color represents the 22 score is significantly lower than 2019. So several weeks ago when we were doing this, we fairly quickly found the table. Once we found the table, we identified the column, and then we could go about jotting down the relevant information we needed to answer the specifics of our research question. And that involved, for a select few states, we wanted to see what their EL score change was or not EL score change was, as well as identify which states had a significant increase in score in one category or decrease in scores in one or more than one category. So when we went to this and when we presented this or when we were working on this, we realized that we got the information fairly quickly. And what happened was that we followed our strict protocols of answering this question. And the protocol involves two separate analysts independently finding the information, which is this table, and then jotting it down independently. And then the two of them come together, they compare notes. Once they compare their notes, they want to make sure everything lines up together. And that's where a third analyst comes in, and the third analyst serves as a senior reviewer. And when it was done several weeks ago, we were like, oh, how long did it take? It took about 10 to 12 minutes. Okay, but it also took 3 people to do it. And we thought, well, it shouldn't take 3 people and 10 minutes to do it. We should have a solution where we can get this information instantaneously. And our solution was build a custom chatbot, which is in line with our corporate agenda of how we can understand and use generative AI. So we built a customized chatbot of our own using Python. And we powered it by ChatGPT using its API, where the LLM is trained on a corpus of our choosing, which for the purpose of this pilot was just this table, and spec'd it so that it only provides answers that are precise. Why did we do this? For policy analysis, particularly ones requiring statistics, if we are to use a chatbot, then we need to know that the answers it provides are valid, which means it's accurate, reliable, which means consistently the same, and is vetted, which means the boundary of knowledge that the LLM is trained on is based on content that we have confidence in. Please note that the latest version of ChatGPT is 4.0, which is available to the public using the Bing search engine of Microsoft and is also available through OpenAI account. However, the API for 4.0 is still under beta testing, and we are in queue to receive it. So this chatbot, the one that we created, is using the version 3.5. Why? Well, we did not want to wait for 4.0 to be released, as the understanding is that 4.0 will be an improvement on top of 3.5. And one thing also we'd like to mention is that our customized bot will eventually become OptiBot. Now let's show you how we built it. Our approach to building the chatbot was to connect the LLM of our custom bot to the underlying data table in 3 different formats. And we used different tools to train them. The 3 different formats were free text, where we converted the entire table into free text because, well, we knew ChatGPT and generative AI works better with free text. Next, our input was an Excel version of the final table that we showed you. And the last input was in JSON format. Why JSON, you may ask? Because we built the table that we showed using Nave's REST API. And as you know, when you send an API a query, the return is in JSON. So we wanted to see, does it understand JSON? And our approach to evaluating the chatbot involved assessing its performance with 5 types of questions. First, identify the single score of a jurisdiction in a student group, identify multiple scores for a jurisdiction, identify multiple scores for a given student group, determine counts of jurisdictions and counts of student groups. And the customized chatbot we trained using the tabular data of our choosing, using the LangChain tool, yielded the best performance, which was 100% accuracy. And once we had it spec'd and trained, we could ask questions like this. We start off with a simple one. What are the score changes for EL and not EL students in Alaska? The response, 9.0 and hash respectively. Now let's check whether it's correct. It is 9.0 and hash. And in the NAPE world, hash means rounds to 0. And then we progress to ask it more and more complex questions. And one of the more complex questions are, how many jurisdictions have a decrease in scores for EL students? List them. The response was 4. Indiana, Iowa, Nebraska, South Carolina. And you can see that it is correct. And it's a complex question because it not only identified it, and it counted it, and we were able to train it such that it only counted ones that were statistically significant. Now let me hand it over to Mark to talk about next steps.
Well, thank you, Sadaf. This is a very informative use case. So as we progress, Optimal will undertake a series of steps to continue to build and validate the progress and processes to ensure that our AI tool is valid and yields valid results. And then, so that's very exciting. And as Sadaf mentioned, we'll be calling it OptiBot. So these steps will include updating from version 3.5 to 4.0, training our OptiBot to understand different types of table structures. 3, allowing users to query across multiple tables and documents within a defined corpus. Validating the summaries, the synthesized information that's generated. And 5th, expanding our pilot using reports and data tables from other federal statistical agencies.